Gladis Zinati, our keynote speaker today, is the director of the Vegetable Systems Trial at Rodale Institute and a soil scientist and horticulturalist. Her research focuses on linking soil health to crop and human health by evaluating the impact of cropping systems excuse me, and management practices on nutrient cycling, carbon sequestration, and vegetable nutrient density. Sorry about that. We are so glad to have her here with us today. Today's keynote will be in a webinar format, so you can ask questions through the question and answer function, and Anna will read them out to Gladys for her answers at the end of her presentation. And we just wanted to let you know that the webinar format is unique to our keynote session, and the rest of our sessions will be in a more interactive meeting format. I will now turn things over to Gladys so she can talk to us about connecting the dots to link soil and plant health.
Well, thank you so much, Ryan, for introducing me, and big thanks to Anna. It has been a great pleasure since Anna contacted me back in June, and she said would like you to kick off our conference with a topic about soil health. And today, I'm gonna share now the screen with you. And let's see. And let me know, hold on, sorry. Let me know if it is coming all the way in big screen now. Can you see it?
Yeah, we can see it, Gladys. Thank you.
Perfect. Thank you, Anna. So it is a great pleasure for me to kick off the conference with the topic linking soil health to plant health. And I'm trying to reduce here all those things so I can see the screen myself. Okay, and linking soil health to plant health, connecting the dots. It is very important to know what is soil health, what do we mean by soil health, and what it is really means to us when we are looking into plant health. So let's start with defining what is soil health, or what is healthy soil. A healthy soil is the soil that can sequester the carbon from the atmosphere. It is a soil that it is free from toxic chemicals and synthetic fertilizers, and it is also porous and not compacted, because it's very important that we'll have a good structure, allowing water to infiltrate through the soil profile easily without ponding the water on the surface of the soil, without any sheet runoff of water from your farm to the streams or neighbors, that it is very important to keep that water during the rain or the irrigation into the soil, not outside your farm. It's also important to be soil healthy when we look at the diverse microorganisms in the soil, because all these suite of microorganisms are important to work together with the plant roots, providing with the symbiosis between the plant roots and the microorganism, all these channels of carbon and nutrients among them. Healthy soil should be able to grow nutrient-dense crops, not only any crops, but nutrient-dense crops, meaning that when we have all these factors all working together, we are looking into a soil that can sustain the productivity of plants and the continuity of human beings and animals. Why it is very important for us? Because in the past few 80, 90 years, human race have been working and doing a lot of work of damage, starting from the infancy of the industrial farming, when the growers started working with the soil, and when they start applying and introducing synthetic fertilizers and chemical pesticides. Give you a little bit of history here. Between the era of 1965 and 1980, you could see an exponential increase in the nitrogen fertilizer. And then it continued and increasing throughout the years. In fact, in this era, it increased twice, double the amount of use. Not only that, but the pesticides themselves, including all the herbicide, insecticides, and fungicides, during the same period of time, you could see there is an increase in the pesticides. Looking here at herbicides, again in the green area here is the herbicides. You could see how much it continued to increase and the amount of it. Along the way, the growers were advised to shift to specialized monocultures, meaning the growers would be relying more and more on those fertilizers, more and more on these pesticides to control their weeds and the pests and any diseases. So that really causes some risk, because once you have damage or you have a disease that comes and wipe up everything, you don't have diversified crops. Along the way, the scientists and breeders would start new programs by breeding more into crop yield rather than the nutrient in the crop, meaning more into a carbohydrate, more into bigger size. You could see that with different varieties and cultivars of vegetables, they increase the size of the fruit, they increase more of the carbohydrate on those ones, on the expense of the nutrients such as minerals or vitamins or antioxidants. Not to mention also the booming of using tractors and different machinery that growers have used and used it intensively, especially when we are working with vegetables. And so all these factors, they are all integrated into bigger problem. What the problem is that every time they really till the soil, that carbon that it has built for many years there is now oxidizing and released to the atmosphere. When it is released to the atmosphere in the carbon dioxide form, it is really keeping more of that over the years. The more you use fertilizers, synthetic fertilizers, it is degrading the quality of the carbon. And that really showed a lot of farms, which you have probably experienced in your areas as well. We experienced across the United States and globally that the more the soil is degraded, you will see more compaction. You will see more of the soil erosion, the sheet erosion of water. And if you are not careful to have contouring, you will see that water could be carrying with it sediments outside the farm to the water streams. It would be causing eutrophication. And so these are problems that we have been facing with. Not to mention that all that gas emission and excess in our globe, it caused the global warming. Those all things doesn't go only to the atmosphere, but we all people will have an impact on our health. So we start seeing more of the diseases and more of the health issues. And in the coming few slides, I will be talking about what we have data on the health hazards and what we have data on how those practices really lower the density of nutrients in the crops. So we have been living with a broken system for many, many years, and we have been using for the past 20, 30 years to fix that system. And it's still going on and it's still having problems with it. So it is not only a wake-up call, it is already people probably have been understanding the problem, but they are still not yet there to fix the problem. In some regions, you will see that people are still using intensive tillage no matter what, and some other places they are not using the varieties that really have the efficiency or the uptake of nutrients better than the others. So until the 2002, you would have seen a rare or a scarce amount of information about what would be the vegetables or the fruits that have any residues of pesticides. For example, Here I show you the top 20 crops that they are shown to be very, they have about 73% of pesticide residues of naming some the strawberries, some of the celery, tomatoes, peppers that we all grow in all regions, cucumber, potato, which is another issue that people have been having a lot of diseases of cancer because they have been consuming a lot of those potatoes in the ground that are contaminated with any of those pesticides. Kale is another one, and lettuce. These are leafy vegetables that are very good for our health, that they are full of nutrients, but whenever they are contaminated with pesticides, it's really going to be absorbed quickly because they are about 97% water, meaning all those will solubilize into your bloodstream. More and more, we have seen data showing an era where more of the younger generation, the children, they have had a lot of diseases due to the pesticides, such as the developmental disabilities, such as the ADHD. Autism raised a lot between 2002 and 2008 and still continuing. But within that era, you could see how much increase, 78%. Also, childhood cancers increase the incidences. We have seen more of those incidences even in the previous 10 years. Diabetes started at early age, not only in the older ages, but in the younger ages, obesity as well. And so these are symptoms that we are seeing them as a result of all those let's say unmanaged or bad management of our soil and our environment. Here there is a data that came in the Journal of American Medical Association telling us about what is the percent of people that are having deductible levels of Roundup or the glyphosate that we apply for controlling the weeds. And those exposures started at 0.02 in 1995, parts per billion. Remember, parts per billion is very, very low. And then it increased significantly between 210 and 215 to 0.77. It is about 38.5-fold increase due to the exposure of people to Roundup. All these are symptoms, these are facts that we have to be aware about and make sure that we stop using all these bad chemicals for our health. So it will really help to have a healthy soil because it has all these factors that I talked about, and it is a security for our food. But when we grow plants, and whether they are for forage or for our crops, for human food, and it is in contaminated, in bad soil, in unhealthy soil, then we are impacting the ecosystem, we are impacting the fodder we give to the animals, we are impacting our crops, and we have seen it. We have seen it took probably 2 decades until we get COVID-19, and that's when it hit us in 2020, and our immune system was really low and was not able to take that virus. And so this is a signal telling us we have to be very more careful about what we are eating and what we are eating, where it is coming from, and how it has been grown. Now and more you will see grocery stores are really interested in learning about and educating their customers about where the crop is coming from, how it is grown. We have contacts with many of these grocery stores, the big ones in the country, and we are working with them about educating the employees and how we can put educational programs to educate the customers that they work or they purchase from them. So this is really a big thing. So the impact of industrial farming was not small, especially on the crop nutrient density. For example, to give you here this graph, at Texas A&M, Davis and his colleagues have published this paper, and I extracted this graph from that paper. What he did, he took garden crops that are mostly vegetables, but also included fruits, and assessed the nutrients that you see here from protein, fat, carbohydrates, calcium, phosphorus, iron, vitamin A, thiamine, riboflavin, niacin, and vitamin C. And so he compared the nutrients in the 1950, and he called them the old, and the 1999 and called them the new. And so the ratio is telling us whether on this y-axis, whether they have declined or they have increased or they stayed stable the same in between these two dates. So if we look at here on y-axis, which is 1, meaning nothing has changed, and you could see that the carbohydrate didn't change in that time because they kept doing the programs of having the same cultivars and varieties that are rich in that carbohydrate. But what you could see that we have decline in protein a little bit, but also we had more decline in the calcium, in the phosphorus, in the iron, as well as riboflavin, even more, and vitamin C. And those are all showing between these two dates, between 1950 and 1999. To give you, to get to this in detail, to give you another idea. So let's take one of the crops. And in this case, I'm taking even broccoli, which is known to be a very high dense crop because it is mostly all dry matter and the nutrients and very little of water in it. So if we look here, in 1950, the calcium, and we are assessing calcium in the broccoli, parts milligram per gram, it was 12.9 in 1950. And if we go with time at 2009, that broccoli will have 4.4 milligram per gram. So what it means to us now that the density has declined, and instead of eating one bunch of the broccoli, now we have to eat 3 times to get what we used to get from that in 1950. That's how much we have problems where the nutrients are low in calcium or phosphorus or iron. And he explained that it is caused, and other researchers from United Kingdom, that it is basically what we are seeing is, we call it the dilution effect. And what do I mean by that? This is a dilution effect caused by the excess of fertilization because it is the plant growing as fast as it can, and also the environmental effects if it is really allowing more of these microorganisms to be not working as much, but depending on the fertilizer. And also the breeding. We talked about the breeding programs. The breeding programs, they really breed their crops to, which we have been using for size and dry matter, meaning yield, meaning more carbohydrate. Those carbohydrates are primarily delivered through the phloem of the crop, through the plant. However, the nutrients, the minerals such as calcium and magnesium, these are really not increasing at the same rate of increase of carbohydrate, not at the same rate the crop or the size of the plant or the fruit itself is really growing. So the fruit is growing, the dry matter is bigger, the yield is bigger. However, the nutrients such as calcium and magnesium are still the same. The plant is gonna take what it takes usually because it is monitored by the xylem. It's not through the phloem. And so these are all factors that really impacted what we grow and what we buy and what we eat and how it's really impacting our health. Many scientists, educators, growers, and policymakers in the past 2 decades or 3 have been working on focusing their work on approaches to build soil health. And those approaches included different methods or different practices or tools, including conservation tillage, organic amendments, diversified crop rotation, covering the soil with cover crops all the time, not only keeping it running through the winter and during the rainy areas where we have in South United States. Also in California, there are we have now what we call the desert area because of the mismanagement of the ground there, the lands, and we have a lot of deficiency in the soil, in the carbon, and that caused drought there. It caused a lot of the air that it is going there not to get more of the rain into the area. It became like a pocket. And so also they recommended grazing with kinds of animals, or sometimes heavy grazing if they want to mitigate soil into a previous probably 50 years, 100 years back. So it would build again all that carbon because of the manure and because of the feeding and the grazing of the animals there. Also, it is very important and documented that elimination of toxic chemicals will really avoid all these microorganisms to be less, or the communities of the bad microorganism will surface and the ones that work with the plant will not be populating. So these about the abundance of these communities. There is a plethora of research work on different aspects of the cropping systems and how they are impacting soil health, from carbon, from pH, from availability of nutrients. There are also the management practices, tilling with plastic, without plastic, amending soils with compost, with manure, with cover crops, on yield, not on nutrients, on yield. Also how it really affects the contamination of any water that has been used, the gray water that they have been trying to use in Texas and California about soil health, and how much of that is really impacting and the residual of it in the soil. There is plethora of research work where it shows the impact of the practices on soil biology, like with the tilling affects the microorganism abundance, or the communities under the use of compost or any other amendments, or let's say using the synthetic fertilizers versus the organic. There is also research shown that the root diseases could be controlled or increased based on the uses of different amendments, how those are really helpful for suppressing root diseases. These are including the compost, this includes the different cover crops, and also how different management practices really impacted the weed control, and how what kind of weeds they became more resistant to the weed control of any of these chemicals. So these are things that have been going on for the past 20, 30 years. But there is a lack of information, and specifically on vegetables, which we all here, we need to be working on and attending to it. What would be the impact of cropping systems and management practices on soil health, but not only on soil health, how those impact soil health into the nutrient quality, the nutrient density in the crops we grow, as well as the environmental health, and how all these, because it all starts with what we are doing, the cropping systems that we select, also the practices that we implement on our soil, how all those would be connected into our human health. So this is a important information we need to keep in mind when we are looking to provide science-based information, because there is a lot of lack of information specifically on vegetables about how we link soil health to plant health to human health. Today, I'm going to talk about how the management practices and cropping systems impact soil and impacting nutrient quality in the crops that I will give you examples from my work. But the next step I will be doing is to connect it to human health. And so there is one research that I found from the West Coast by Reynolds and his team that shows, and it was on strawberries because they grow a lot of strawberries in the West Side. And they compared the quality of the soil and the quality of the root, and in the quality mean the nutrients they assess when they are growing the strawberry in the organic and the conventional. And here is their conclusion and significance. It says that our findings show that the organic strawberry farms produce higher quality of fruits when for especially ascorbic acid, vitamin C, and the phenolic compounds, and that their higher quality soils may have greater microbial functional capabilities, because functionality is coming from the exudates that the plants are giving to them and the enzymes that are produced by their these microorganisms, as well as their biomass and population and their resilience to stress. So this is the only one that I found about looking into what would be the system's impact on soil quality and nutrient quality in the strawberry. So as I mentioned in my work, when I start working on this issue, I said, well, we really need to look into how we connect the soil health to plant health into human health. Although it will take several years to get all that together, especially when we are working with the human health. But we need to start somewhere, and this is very important to address in the coming few years. And for that, I established and created the idea of the vegetable systems trial that I am showing you here. The vegetable systems trial was created, the idea, in 2013. And then with funding and supports from different funders, gracious ones, we started this vegetable systems trial on 2.62 acres, where we are comparing side by side organic systems with the conventional systems using different measurement practices, which I will talk about, and also different crops, vegetable crops. This project is put in a way that it will run indefinitely with a local, national, and international scope. The vegetable systems trial, it compares side by side. Each block will have organic and conventional, and within each system, we are testing intensive tillage intensive practices along with regenerative tillages or reduced tillage. It depends on the crop. And the ultimate goal is to provide those science-based information to our growers and consumers, because it is very important to link soil health to nutrient health and then work with the human health. These are the different equipment we have used when we are talking about intensive tillage, which many of you probably have used already. This is the Mouldboard Plow. This is the site where we have the cover crop grown during the springtime, and then we plow it under. You could see the soil has been tilled upside down here, and then we disc it, pack it, put it plastic. And next to it would be the one that keeping the cover crop, and then we roll crimp it in one pass, so it will really reduce the disturbance of the soil. Here's another video I'm gonna share with you. Again, these are the plastic mulch that we prepare. It was before the hairy veg that you see the purple flowers here at flowering and rice. So we plowed all that and disc pack and put plastic, but here we are rolling it. And you could see that by rolling it, and we have on the tractor hooked the monosem, which is a equipment that allows us to use while we are rolling to seed into the ground in one pass, such as snap beans, such as any kind of. Here is comparing the same thing, the same equipment when we applied the herbicide glyphosate, and then we also seed into it the conventional beans. This can be used for corn, sweet corn, any seeds that could be useful. However, when we are doing the system in the, not starting from seeds, but from seedlings, we use the no-till transplanter. And that no-till transplanter is used first on the organic system, and then we use it on the conventional. We don't go from organic to conventional, conventional to organic, because that really affects the tires and collecting soil. So always we clean in between, and always we make sure we cover all the organic first, so we don't cause contamination from the conventional to the organic. The different crops that we selected based on suggestions and recommendations from the advisory group, those the growers, the extension educators, the scientists from different universities that join us. These are the snap beans, the lettuce, the sweet corns, winter squash, and potato. And those represent a fruit, represent a leaf, and represent a root. And so we couldn't put more into that. I know that we have over 200 varieties and naming or crops, but also there is a lot of cultivars among all those. We cannot afford to do all these practices and cropping systems on all of them, but we selected the mostly produced in Pennsylvania and the mid-Atlantic, so we can make a better representation. So the vegetable systems trial is really running under the same soil conditions, under the same climate conditions, using the same equipment for both systems, even with the practices with the tractors that we are using. So it is really more homogenized and less variability among other places. So in the next few slides, I'm gonna give you some highlights of the research, because I wanna share with you how the soil health is important and what we got out of it with those different cropping systems and practices, and also link those to the nutrients in the crops that we grow. I'm gonna take also highlights from those. So let's start on this one. This graph if you look at the y-axis, here I'm looking at the soil health, and I took a parameter here, or an indicator. We call it the labile carbon or active carbon. And excuse me, and the labile carbon is very important because it tells us about how stable is our soil, how the organic matter stability is there in the soil. So the brown bars that you see, it is the soil analyzed and taken at 2016 when we started, meaning before we start taking any, before we put even the crops there and tilling and doing all that. So that's our reference line. And then the green bars represent those soils samples that we took in 2019. So in the x-axis, you will see conventional represented as CNV, organic represented as ORG. The tilled with plastic intensive, we call it black plastic. It's represented by BP, and the reduced till or regenerative tillage is represented by RT. Definitely, when we started, you could see all the soil is homogenized and the same, and you could see the labile soil carbon, it's about 700. They were all the same, no differences. However, after 3 years, after 3 year of growing seasons, which constitute 1 cropping rotation in the whole system, we found that in the organic system, in the green bars, that are much higher than the conventional. Yes, there is some increase here, but was not so significant. But you could see that the labile carbon is really showing much higher in the organic system. So that significant difference after 3 years from initiation was there, irrespective whether we have reduced tillage or black plastic. At this point, only the system really mattered and impacted the labile carbon, not the practices such as tillage reduced or intensive tillage. Here it is about the soil protein, and on the y-axis telling us the percent of protein, and then here it is telling us about the conventional organic and in both practices. Definitely the 2016 also, it is the blue bars, nothing happened, they are all the same. 2019, we have a significant increase of the protein in this area, in the organic, in both the organic plastic intensive and again, it's not showing us till now that the practices is really affecting the protein as well. So we talked about labile carbon, we talked about the protein is not really affecting, but it's showing it is increasing, but as not as in the conventional. I would like to see this in after 3 and 9 years to see how those data will show differences between the conventional organic, and hopefully we will start looking into changes and differences between practices, because all these take time, and the vegetable systems trial is set to be running indefinitely a long time. So this is very important that we can continuously taking soil samples and plant samples and relating them to each other. In 2019, in addition, I did a deep soil course, and it's like this time. Next week, we will go and get some soil cores in the vegetable system trial. And we took those up to 100 centimeter deep in the soil. And when we went to the lab, we sectioned them at 10 centimeter each for the first 30 centimeters. And then this next 2 sections were about 30 centimeters. And then the next one would be 40 centimeters. Mainly, we want to see where in those we have more microbial biomass. We want to look into the communities. We wanted to know what functionality they have. we were working with colleagues from the Strauss Center to assess those. We have been looking also about the mycorrhizal fungi, but we don't have yet all the data back because it takes a lot of time. And the problem that we had with closing labs during 2020, and part of it was working 21, is really put us back in getting all that data out. But I'm gonna share a few things with you today. So here's a soil, and we took that deep core, and I'm gonna show you information between 0 to 10, 10 to 20, 20 to 30. And here I am showing you data on nitrogen and carbon, although I also worked on POXI, which is the labile carbon, organic matter, and minerals. So let's look at the percent nitrogen. Percent nitrogen here, I'm looking conventional and organic. You could see here in all the depths, we had pretty good amount of nitrogen in the soil. It is an okay amount in the conventional between 0 to 20, but it becomes really very, very low beyond 20 centimeters, meaning anything growing beyond 20 centimeters in the conventional will not be able to get better nitrogen as we get it here in the organic. When we look at the carbon, even worse. Worse because you could see that the organic is really good. It's keeping ahead with the carbon, which is pretty good, between 2.5 and 3.3, meaning it's really good. However, you could see that the conventional, that's in 2019, and we see that it is pretty low in carbon. And if you go with depth, it's really very, very small, meaning this is not providing enough backbone for the crops that would be grown in the coming few years. This is very important information to see and to work with. So now let's connect the dots between soil health and plant health. Here I'm giving you some highlights about the sweet corn, one of the crops that we are growing in the vegetable systems trial. Again, I'm talking about protein, and protein based on nitrogen. We knew that nitrogen in the soil was high in the organic and lower in the conventional, and that's same year in 2019. And so if we look here, again, you could see that the protein in the sweet corn was much higher significantly than in the conventional. There was no significant difference at that time between practices, but it tells us a story here. It tells us something that the organic management, the organic system is providing us with higher protein. I want also to show you here between 2018 and 2019, just as a comparison, we assessed vitamin B6. Vitamin B6, there was no significant difference, anything in 2018 and also in 2019. But when we compared year to year, we found 2019 much higher. If you look at this compound in the structure, it has nitrogen, meaning it depends on nitrogen, meaning it is really affecting whether there is nitrogen in the soil to help that crop to take that nitrogen and put it in the harvestable crop. We also worked with potato. All the years, we used one of the cultivars that it is pretty good in growing in our region here called Lehigh potato, and Lehigh potato was really bred in Pennsylvania, in Lehigh County, where I am really from here. But let me talk about Lehigh a little bit. Lehigh, it has a tan color, and it has a pale yellow to creamy color flesh. And also in 2019 and 2020, we tried to introduce another cultivar, the Purple Majesty. As a matter of fact, the Purple Majesty, we bought it from main growers there. So this should be available in your area and should be able to grow it in your area because we got it from there. However, let's look here at the protein again. So the Purple Majesty, the one we selected, it has a purple skin with a purple flesh. There are other cultivars of potato that you will say, oh, they are purple from outside, but they are white or tan color. They are not the same quality as those ones that they are filled with pigments. We call them anthocyanin compounds in them. Because what is this purplish color, if you remember, also strawberries has the red, also the bell pepper has it, the ones like purple cabbage, all those ones, they have anthocyanin in different levels. And so in the Purple Majesty, it is filled and packed with anthocyanin. If we look at the Lehigh, it has zero, nothing anthocyanin in it. But if we look at the protein here, we see that the organic system, again, was high in protein, allowed the protein in Purple Majesty to be higher than the conventional, as well as for Lehigh. And you could see differences even in the cultivar. You could see that the Lehigh was more efficient in taking that nitrogen and build it up as a protein. And so it was much higher, but not as much higher in a way than the Purple Majesty. But that's something to tell us that if we incorporate and we diversify even our diet, not only white potato or yellow potato, but we put a potato of different colors, especially the ones with the purplish or reddish, like Mountain Rose or Yukon Gold. If we put in our diet all those, we are reaping the carotenoids, the anthocyanins, the proteins, all of it together. So it is very important to understand these things and what really impacts the value of the nutrient based on what we are practicing. Here in the Lehigh and Purple Majesty, I assessed vitamin C, again in the same year, and you could see that was no impact on Lehigh. It was the same, not even on the management practices, but we saw that in the reduced, in the conventional was much higher, and that the organic in the vitamin C. And that could be a reason because that the plant is not as efficient in a way for certain elements, but it is really suppressed by certain elements that it may impact the vitamin C, which we are looking into it right now. These varieties or cultivars, we planted them again in 2020. So we wanted to see if there is a chance in the future to incorporate on a bigger scale different cultivars to see their nutrients and how they are impacted by practices and systems. Here I'm showing you the totalphenols. Totalphenols, like in the West Coast, by Ronald and his team talked about strawberries with the totalphenols. It is one of the nutrients that they assess. Totalphenols are known for anti-inflammatory, antibacterial, antiviral, important for the immune system. It is exactly what we need these days. We need them not today, not yesterday, not 20 years, we need them every day for the coming 100 years. And every generation should be understanding how these totalphenols are really important. We did not see much differences across the cropping systems when we did the totalphenols, but we saw across the practices here. Definitely not impacting Lehigh at all, the totalphenols, but we saw that it is more in the black plastic than in the reduced tillage. And one explanation for that, because totalphenols are reactions that the plant is having to one kind of stress, such as the pest in that case, or it could be any disease. And so in 2019, we had a huge amount of leaf hoppers and also a it was the year of more of the potato beetle there. Mostly the ones with the black plastic were impacted. And so that's a sign of the plant is producing more polyphenols as a reaction. And that's why we saw it more significantly than the reduced tillage. But the story here, the take home, is that you could see Purple Majesty is really giving you twice the amount of the polyphenols. That's another important factor as a nutrient. So we can look into how we produce more of it. So the next phase that I'm working on and continuing for the coming 10, 15 years is not only to look into soil health, plant health, but connected with human health. I'm working with different entities now, with universities and medical schools, where we are looking into researchers there that they can use the crops that we produce and do some benchtop experiments for certain diseases like cancer cells or something, as well as we are looking for the future to work with groups of people that we can feed them different crops from different management or different systems, and monitor the urine, monitor the blood, monitor their health. And so this is a big scale, but we are still in our first steps into it. Like Anne Gibbons said, food is only as healthy as the soil in which it grows. And we have to be always looking where, when we purchase and consume our food, where it is coming from and how it was grown, in which kind of soil. That's very important. We have to teach our children, our grandchildren, because they are the ones who are gonna carry it from here on. It is very important to keep that message in their mind. How we farm impacts a lot of our soil carbon. We can reduce all that carbon dioxide in the air and that gas emission and put it back. We can keep it and put it back by using different approaches and management practices. In this conference, you will hear this evening, there is a conference, there is a presentation about carbon. There you on Wednesday and Friday, there would be other presentations from colleagues and who are working on water, who are working on stressors, and who are looking into how the soil is used and how that affects climate change. I really recommend that you attend all those because they all feed into this whole big picture. And we are all working from different angles. And we are all here to help making better system, better ecosystem, better earth. And so it is very important that we look into that. And also not to forget, on Saturday, I'm gonna give a half a day of workshop on carbon farming. So keep tuned to all these presentations that Anna and her colleagues put all together. This is a fantastic conference. And so it will really help you to learn more and put the puzzle together. So what it means, the bottom line is go regenerative organic farming, because it is the way to go, like nature. Nature did it that same way. And it is really gonna help you to increase your crop nutrient density. It will help you to sustain the food security and also the ecosystem. The animals that we produce or grow there are really healthy, and also we have healthy communities. And with that, I'd like to thank you all for listening to this presentation. And I hope I inspired you and put in you hopes and congratulate you on what you have started working with, and to continue expanding your horizons. Not only, okay, I'm using what the educator told me to do a reduced tillage, but think how is really matters to the next step. How am I gonna get a better nutrient dense crop? How I'm gonna sell a better and nutrient dense crop to my customers? How I gonna be having a better price? How I'm gonna feed my family with healthier food? How can I feed myself as a grower and sustain that? These are really the information that I hope I put together to give you that inspiration. And back to you, Anna, and for your questions.
Thank you, Gladys, so much for your wonderful presentation.
Thank you.
The first question that came through was wondering if you would be willing to share those slides with us.
Absolutely. Absolutely.
Oh, perfect. So Gladys will send it to me and then I will send it out to all registrants by the end of the conference.
I would be put them in a PDF, but just make sure that those data that I showed you are not yet published, but they are going to be published. And so I just wanted to make sure that you are up to date with what we are doing, and we are going to publish those data out.
Perfect. So nobody publish them in the meantime, please.
That's a good one.
So another question that came in was wondering if it's no longer just the Dirty Dozen and the Clean 15 anymore.
Yes, it is not, because, you know, when they assess things, they assess them on certain chemicals. And now we have different chemicals, and they have there are new crops probably will show more impacted by the pesticides that have been used. So give you an example, and that's a very good question. In the vegetable systems trial, now we are starting to take samples and assess them for pesticides that we applied during the season, whether they are conventional or organic, fungicides, insecticides, even the glyphosate. And we are taking soil samples at the same time, before and after. So we are trying to link whether those ones that we are using that are approved for conventional or approved for organic will show up in the fruits that the vegetables that we are collecting. And we are going to put that over many years, because, as I said, it takes time to show. And so maybe yet is not gonna show, maybe a little, but we want to, like the graph I showed you about the glyphosate, they took an era of 10 years and they chopped it into different times. So it is really important that we look into those items and see if those made any difference in the practices as well.
Thank you, Gladys. One question that came up is, what were the fertilization practices and inputs for the conventional and organic treatments in the VST?
Yes. In the conventional, we use urea and we use potassium chloride. These are the two synthetic fertilizers that commonly used by conventional growers. In the organic system, we use compost, and because of the rotation, we put the compost into the area where we plant the potato, but that land would be rotated with other crops such as winter squash and beans. So that land gets one time that with compost, but over the 3 years, the whole vegetable systems trial gets all of them the same amount of compost. Now, in addition, we use different also fertilizers. Some of them we use the blood meal. Some of them we use the 307 from Fertrel. So you could see that I haven't been using any phosphorus in the conventional or the organic. And that's because our soils, when I did the analysis, it was high in phosphorus. So there was no need to add any phosphorus to it.
Thank you, Gladys. This next one is kind of a long one, so prepare yourself.
Okay, maybe we can take it as chunks.
Yep, I can try. How does a healthy soil with higher levels of protein and active carbon impact carbon in the atmosphere? And then the follow-up is kind of, does a more biologically active soil increase atmosphere-borne CO2 or reduce it, or neither?
Okay, that second one will answer it, but you have to read it again for me.
Yeah.
So the first one is that, can you repeat the first section, please?
How does a healthy soil with higher levels of protein and active carbon impact carbon in the atmosphere?
Okay, now the protein in the soil and the active carbon is not released to the atmosphere. It is there for produced by the microorganisms and feeding it through the plant roots. So how it really impacts the carbon dioxide only when you are really tilling that soil, you are really disturbing that soil. That active carbon that has not been used, it somehow, part of it will be oxidizing, and the protein will be not too much to be chopped unless there are other factors, microorganisms, and availability of temperature and water. The second section.
Yep. Does a more biologically active soil increase atmosphere-borne CO2, more actively decaying organic matter, or reduce it, increase capacity of plants to pull CO2 out, or neither?
Okay. Now, when we have a soil that it is active with microorganisms, their activity, it comes from the use and having plants next to them. Those organisms, when they are active on the plant roots, could be active on having the residues there. So they are working on it, but their full capacity of activity will be always when they have that relationship with a plant that it is living. So their activity will change and their reaction would be, if that residue, they are using it actively, it would be helpful if that residue is more in the form of lower carbon to nitrogen, because they can be active and using it immediately rather than having a big bone sitting there that they are really could be impacted by any of the damages, or could be impacted by tillage that they can be oxidized. So when you provide them with residues that are with lower carbon to nitrogen, more of nitrogen, then they can be helping the nutrient cycling and helping the plants. When it is an area when they are really working on that and there is no plants next to it, it is really not going to be, in my opinion, to be really dramatic to emit that carbon, because especially when we are talking about activity, those guys are gonna work when the plant is giving them the help with the carbon, or the residue is there if those microorganisms work only on the residue. If those are not available, the microorganism will not be active. This means there would be no issues for anything to go into the atmosphere. But when they are doing that, which I suspect very little will go into the atmosphere, but it will recycle with their dead bodies as necromass and stay in the ground. And that's where it builds the humus in the soil. I hope I answered that question. Would this same person has anything that I didn't answer you?
Yep, I think you covered that, but they can certainly write something if it wasn't covered fully.
Absolutely.
Next, there's a question, are you looking at eggs or animal meat in the same way, analyzing the nutrient densities?
I am not. I am not working with eggs or animals, but we have programs and there are other farms and other researchers in Minnesota where we have back, yes, 2013, we did work with USDA and other entities, universities. I need to take a sip of water, excuse me. Okay, thank you. Where we looked into livestock for the milk. And we had growers here who had cows that they were in transitioning, and cows that are conventional, and cows that in the organic. And so we collected milk from them, and there is a publication that showed that the milk that in the organic was really higher in fatty acids than those in the transition or the conventional. That's one thing that was very significant, that the kind of fatty acids was much higher for those who were in the organic system. As far as meat, there was work done in conjunction with Minnesota, but it was not organic and conventional. It was about grazing. But there are other places where they are doing that, I believe.
Thank you, Gladys. Another one a little bit related to animals. Do you know how animal feeds affect manure for composts? For example, is no corn, no soy feed for chickens better for soil health when using the manure?
I didn't get that question. Could you repeat it slowly, Anna?
Yeah. Do you know how animal feeds affect manure for composts? So for example, is a no corn, no soy feed for chickens better for soil health when using the manure?
Oh, so if you are feeding the animals no corn, no soy, but you are feeding them what? The grass that they are outside grazing? Is that what you mean?
I imagine they would mean that, or maybe some no corn, no soy feeds.
Okay.
I think they're just wondering if feed for animals affects the soil health benefits of the manure.
Okay. One thing that was found, one of the research that I read about, that animals that they were, maybe it fits into some of the answers for this person, that when they were, animals were confined, meaning that they are eating whatever they are giving them, corn, soybean, and those that they are grazing outside. So they were not given those feed. They found that those animals that are feeding on grazing, they were helping the soil to regenerate the grass again, and the roots of those are growing faster and deeper into the soil, meaning more exudates, more microbial activity. At the same time, also, they found that the manure, which is outside, has distribution more with the microorganisms. The ones that they were always confined, of course, they have been fed, but they found that the manure, they have to collect it and put it outside, which is totally different from that. Now, if they are not given, because I am not an animal scientist and I didn't work on animals, but if I would be saying no corn, no soybean, but they are grazing, I will believe it would be much better for them because that's their nature. Their nature is to be outside, not to be fed with corn and soybean. And their manure, especially I'm talking if it is organic, if it is having anything that has GMO and glyphosate and all that, that thing is gonna be in their meat, in their, if they are cows, they would be in their milk, and those things will be also excreted. Most of it will be excreted into the soil. But I don't know if there was anything about using those manures, how it impacts the soil health. It only, what it excretes out, it really matters and depends on what they are feeding them. Something other than corn and soybean, I'm not really sure.
Thank you, Gladys. The next one says, for a new farmer just beginning to learn about soil I'm working with, what are the first steps you would recommend taking to establish a good soil foundation on which I can build these sustainable soil management practices going forward?
Okay, few things you need to know. You need to know your soil. You need to know what type of soil and what is the history of it. That history is really important for you because you need to know if it has been managed, what type of management, what type of equipment has been used there. Also, you need to assess these soils at a certified laboratory for the structure, for the texture, for the density. If your soil was dense and found that it is dense, bulk density is high, then you have to do something ahead of time to prepare your soil to make it spongier, meaning that you need to open those pores out so they will have pores so it is not so much dense together to allow air and water to go together. In that case, you need to learn about the bulk density, which is very easy to know. And then you can assess if the bulk density is good and it is not a problem, then look for the nutrients, and that nutrients tells you something. If the nutrients is high in certain, you don't apply it. If it is low in certain, you apply, and you apply in a way either through using different cover crops, and those cover crops will tell you which ones. And usually growers, especially the beginners, should work with educators, with extension people to help them out, lay out the things. Now, we have a program here that we established a year ago. We called it the consultancy program, and it is booming. And we have been going into different states. And so these could be also helpful for you to connect with them. If your soil has some issues with, let's say, infiltration, and you can test that after a rain and how long it takes for that rain to go through it. If you see that it is taking more than 2-3 minutes, or depends on the intensity, of course, or it is taking hours, then you know it is compacted, then you have to do something. And you can do something by adding compost to it, because with time, the compost is going to make more of those porosity, and you can use it in a way to help opening those channels. Also, you can use a deep-rooted cover crops that really helps in breaking that compaction. One of them, tillage radish. If you can't, you use something else like sorghum, or you can use what you call that, sun hemp. Those have deep rooted that they can break, but tillage radish is pretty well known to open those pores and help you in improving. If you know that your soil has been impacted and really you need time, give it time. It takes probably a year or 2 or 3 years to get it to the place where it is not yet ready for it. So you could put some alfalfa and take hay, and then after that, you can start. However, let's say your soil is good, and what type of management practices you need to continue working with. You need your equipment to be practiced in a way that it is the least disturbance for you. Now, if you have lots of weeds, is your best bet. Do not start immediately. You have to manage the weeds because they are number one problem for you. So in that case, manage the weeds for a year or two to make sure that you reduce your population of the seed bank of those weeds there. If the weeds is not an issue, then the way to manage it is to make sure the least disturbance, use equipment that doesn't flip the soil upside down, use management practices, probably strip tillage or something. And that will really build with time integration of different things. I am telling you a few things that I'm gonna talk in the workshop, but you're welcome to come then and listen more.
Thank you, Gladys. We're hitting perfect timing here. We've got one more question and just a couple of minutes left. What soil quality metrics are you observing in addition to nutrient density measures in the VST?
Okay, the soil that I'm working on is that we are looking all the biological, all the chemical or the physical. We are looking into the microbial biomass, bacteria and fungi. We are looking into the pesticides as well. We are looking into the communities, mycorrhizal fungi, different. We are trying to find which communities are more abundant and functional. We are looking also into the protein, the mineralization in a way that what it takes for mineralization. We are looking into organic matter, all kinds of minerals, macro and micro. The bulk density is the one that we use, of course, throughout the deep core, but also during the season. Also, we are doing infiltration. We are doing the compaction using the penetrometer. Those are the ones that we are using.
Wonderful. Thank you so much, Gladys, again for your presentation and answering all these questions. And we'll see you specifically on Saturday for those who are attending the intensive. And you can let me know if you've decided to change your mind and want to attend. And other than that, I hope to see everyone at our sessions tonight, starting at 6 p.m.
Perfect. Thank you so much for inviting me, Anna, and your colleagues. And thank you, Ryan. And it is really a great pleasure to be part of your conference. And I hope it is gonna be a wonderful week for everyone to reap a lot of information. I saw that the program is really diverse, and I love the topics that you had there. And I realized that we can only see one item per day because I also registered. We cannot go to more than one. I wonder if all those would be recorded. Maybe I can listen to the other ones afterwards. Would those be recorded, all of them?
Gladys, what a great question. That is the number one question I get. Yes, we record pretty much all of the presentations of our sessions. There's a couple of outliers because the sessions are completely discussion based. But yep, so our sessions are mostly half presentation, which will be recorded, and then the other half is discussion, which we don't record just so people can feel free to discuss whatever they want to discuss. But yeah, we'll be sharing all those out about 3 to 4 weeks after the conference.
Amazing. Thank you so much for all the good work, Anna.
Thank you. And thank you, everyone.
Thank you all. Ciao. Bye-bye.